Hi, it's Mike, VI3MW, and I'm here with Tony, Kilo 1 Kilo Papa. Tony's been part of FlexRadio for a number of years, and Tony's going to tell the story of Polar Explorer, polar modulation, a technology called, I got to look it up, envelope elimination and restoration, which, you know what, it's just cool. So, Tony, welcome to this interview.
Hi, Mike. Glad to be here.
Good. And we're recording this about a week before the announcement of the product. So we're really excited about this. So without, as I say, any further ado, let's get started. Tony, what inspired the idea for Polar Explorer and what problem were you originally trying to solve?
So one of the neat things about ham radio is that there are so many little sub activities that you can do. You can be interested in digital one month, and then another month you're interested in DX or something else. And people don't always do the same thing in ham radio. They kind of move around and they have a kind of a journey through the hobby, I'd say. I think my journey was fairly typical. When I finally settled down and had a house, I got back on the air and got into HF. And of course, the interesting thing about HF is that you can make long distance contacts. And so then I got into DXing and started chasing DXCC. And the thing about DXCC is that it's real easy in the beginning. You can work a lot of new ones, but then sooner or later you start to run out of contacts and places to contact that are really new ones. And then you learn that you can maybe get a few more new ones if you get on during a contest. And that kind of got me into contesting. And so I was really seriously into contesting in the early 90s. And of course, then children happened. And that meant that I couldn't commit to any particular activity at any particular time. So I took a little detour away from contesting in the early 90s, and I got into restoring boat anchors, which is restoring older ham radio equipment. I restored a couple of Collins transmitters, had a set of Gold Dust Twins. I restored a KWM2. And one of the things that happens when you get into restoring boat anchors is you have to get on AM, because the older transmitters were all mainly used in the AM mode. So that got me on to 3885, which is a whole kind of genre in itself. And one of the neat things that was going on 80 meter and 160 meter AM, a lot of the AM guys were developing these Class E rigs, which are highly efficient rigs, very easy to AM modulate. And it's very simple to make a lot of high efficiency power on AM. And I would get on there and I would listen to them on their AM Class E transmitters. And it just sort of seemed obvious to me, like, why wouldn't you want to do this on sideband? That would be really cool to do it on sideband. And it also seemed kind of obvious to me that all you had to do that was phase modulate the carrier. And so this kind of made me think that I had invented something. And if you're a creative person, you're into inventing, and pretty soon you realize that there's actually a subtle distinction between inventing something and innovating something. If you invent it, I'd say you're really the first person on earth to think about the idea and to put it down on paper or make it work. But it turns out that the idea of a high efficiency transmitter using a switching type amplifier was really invented by Leonard Kahn in 1952, a year before I was born. And so I filed the idea away. And so many years later, finally the kids had grown up and retirement happened, and I needed a project to keep me sharp. So I dusted off this idea and started working on it. I started working on it with a ham friend of mine, Brian, K1LI, and we kind of got started at a lunch before a Yankee Clipper Contest Club meeting, and we worked on it together for about 5 years. And The technique of envelope elimination and restoration uses polar modulation, and so we capitalized on that name, and we kind of mixed it with the idea of explorer for investigative or an experimental project. So we came up with the name the Polar Explorer, which is what we call the project in the early stages. Plus, it kind of makes you think about cool areas, like polar exploration. So the name fit pretty well.
That's quite something. And I was searching while you were chatting, and I'll put this up here. We have you have an article on QEX, and I found it just simply by searching for Polar Explorer in your call sign. So if you want more of the technical jargon, wonderful. Moving forward, can you describe the biggest technical challenge that you faced during this development?
So there were several technical challenges, and that's part of why it took so long to get from the very beginning to the point where we're at now. I would say the first challenge was in finding semiconductor devices that worked at high frequencies and high power, and that were fast enough for this kind of amplifier. And so it was a lot like if you've seen the movie about Tom Edison when he was inventing the light bulb. He tried everything he could imagine as the filament for his light bulb. I did the same thing, basically bought samples of every kind of transistor there was in the Mauser catalog. And I spent the summer of 2016 trying each one until I finally found one that worked. So another technical challenge was being able to make the amplifier work on all of the ham bands and even get it to work on 6 meters. So the QEX article that you talked about was our very first example of a polar modulated transmitter, and it was 40 watts on 40 meters. But in order to really make something useful out of it, I knew that we had to be able to cover all of the HF hand bands. And so I had to come up with a way to make that happen. And I came up with a basic idea in a couple of days, but it actually took months or years to get all the kinks worked out. And by kinks, I mean parasitics. A third challenge was pre-distortion. Our technical goals for the project were loud and clean. And from the very beginning, the very first version that is written up in that QEX article, that transmitter had pre-distortion capabilities built into the hardware and software. And I was able to leverage that experience when I got on board with Flex and helped with the development of APD. So overall, it was not an easy journey of development. There were a lot of failures, a lot of smoke and sparks. There were a lot of times when I just felt a feeling of cold panic, like this was a stupid idea. I was tilting at windmills. A lot of times I had to step back and literally go back to school to learn some added engineering skills. And over the years, I've learned just an incredible amount of RF design engineering techniques. I discovered that the lack of design information for the kind of amplifier that I was trying to build, the fact that I couldn't find anything on the web, was a clue that what I was working on was unusual and unique. And that just served to fuel the fires of my ambition and my stubbornness. Sometimes it took weeks of careful measurements to get to the Sherlock Holmes moment of the one thing, however improbable, that was left.
What new things did FlexRadio help you with this design and bringing it forward?
So I'd say that the biggest change for me was going from working from a big company. I spent my 35-year professional career with Hewlett Packard and Philips working on medical ultrasound. And so it was really a change, a transition for me to go from working from a big company to a small one. And it was very positive. It was a terrific adjustment for me. The Flex environment lends itself really well to agility and flexibility. Sorry about the pun. But of course, there are limitations as well in a small company. So I find it was much quicker to make decisions, but it takes a lot longer to fund those decisions. And another thing that's different is the flexibility of people. On a Friday afternoon, Steve Hicks, the CTO, might be putting the finishing touches on a $10 million bid proposal. And then Saturday morning, he's in the lab with a soldering iron, putting the finishing touches on a batch of PC boards.
We're going to get this question fairly often. There's no provision for out-of-band transmit. This is an amateur-only device, so Mars and CAP, CFARs, whatever you want in other parts of the world, not doable at all.
So part of the key to getting high efficiency is having a tuned tank circuit in the PA. So we have to have a tank circuit for every band where we're going to operate. And it was a challenge, as I said, to extend the frequency coverage to include the 11 HF ham bands and then also include 6 meters. So the circuit design does provide for a few more choices than we're actually using. And we have actually learned recently of some techniques that can extend the frequency selections we have a little further. But to get the product to market as quickly as possible, we chose to concentrate development of the product around the ham bands only.
I thought 18 pounds, but it might be a little bit less.
Mm-hmm.
Okay. And it fits in our same Flex 6000, 8000 cabinet complete. I asked Tony to go look for the power amplifier pallet, I guess, but he's got one in his hand.
Yep. So this is a very early version. You can see it's got a lot of rework and wires on it. But this is basically the PA board. This one board generates 500 watts on HF and 200 watts on 6 meters.
Quite some time ago, you met up with Steve at FlexRadio. When did this all start? What's a little bit of that history?
So my personal goal for the project was to make a contribution to the state of the radio art, which is one of the 5 basic principles for the existence of amateur radio service in the U.S. It's outlined in Part 97. And to do that, I realized that it had to be a commercial success, not just an article in QEX. So in 2019, I went to Dayton, not as a attendee, but as a vendor. And I put together a booth and a marketing story. And I went to demonstrate the Polar Explorer as a works in progress. And I hope to connect with a company that would be interested in developing the technology into a commercial product. I was really lucky that Steve Hicks came by my booth on Saturday afternoon and he heard my pitch. He instantly got it and recognized the potential immediately. And I also spoke with Gerald, who gave me a critical piece of advice, which I have never forgotten, for working with Flex. He said, "We like to work with people who are smart and humble." Smart, I figured I could do. Humble was going to take some work. We arranged for me to bring the prototype down to Austin for a demo. And I visited Flex and I worked with their engineers to demonstrate and evaluate the technology. The testing started off pretty easy at first, and then slowly ramping up the stress and risk until the last test, which was shorting the output of the transmitter while running 500 watts at the time with a screwdriver. I was inwardly amazed when it properly shut down and protected itself. But of course, I kept a straight face. After that, we worked out an agreement to work together to develop the technology. And over the course of the 6 years, I gradually became integrated with Flex and worked on other projects as well as the Aurora project. Gained just a ton of RF experience working with Gerald and the other RF gurus at Flex. And I learned the people and processes of everyday development at Flex, which really helped once the development of Aurora got into full swing.
Next question is, since the first prototype, which I showed on the screen, which I can share again, and today, what have you learned in the last 6 years that you had no, that was holy crap, I didn't think of that.
Well,
probably many.
I think the biggest thing is that developing a new product is hard. It's really tough in today's environment. COVID was a setback that completely changed the way Flex operated, but Flex adapted and survived and came out of it better off at the end. The current international trade environment is another challenge, which will have unknown impacts as well. But having a great team that works together and supports each other makes all the difference. I've learned that Flex is comprised of a unique group of great people. There isn't one person I'd want to replace. It's hard to imagine, but they're all great people.
A new amateur, new ham gets his off the top of the list, his new Aurora radio, which comes in 4 different models. What's he going to notice first?
Well, probably the first thing he's going to notice is the weight difference. When they go to lift it out of the box, it's significantly lighter than any other 500-watt amplifier or transmitter they've lifted before. I think that's really what's going to be the first thing they see.
And the one thing I want to add is you don't have to learn anything new. If you're a smart SDR user today, the operation's identical, correct?
That's right. They've leveraged all of the aspects of Smart SDR, all of the features and integration is the same. So it'll be very familiar to anybody who's used Smart SDR.
So, simple question: what's next? And I know we're not done with this.
This is really only the very beginning for this technology. And as is typical of disruptive technology, there will be performance improvements to come with further development. And also there will be new undiscovered markets for it as well, and other applications. So I hope to continue as an advisor for Flex and give some guidance to future development. Perhaps not as much hands-on holding the soldering iron 24/7 as it's been for me. I just hope that I've been successful in transferring the knowledge and know-how to Flex so they can continue to develop and grow the technology further.
Well, I wanted to thank Tony for taking some time out of his morning this morning. Don't forget to check his QEX article. You can find that by simply searching Polar Explorer and his call sign Kilo 1 Kilo Papa. You can go to his webpage at qrz.com for Kilo 1 Kilo Papa. There's also a link there to get to the PolX technology page, which has a bit more of the history of the Polar Explorer. And Tony, again, thanks for taking some time out of your morning.
Thanks, Mike.
Okay, 73, everybody.